everyone. We are so excited to have you join us virtually for this build session on responsible ML, getting started and analyzing your models. My name is Marnoush Simiki and I'll be your session moderator. I'd like to highlight that there is a dedicated area for you to ask your question, and there's a team of my colleagues there answering all of those questions. That will help us make this session completely interactive, and I'll make sure to bring some of those questions and ask them to the presenter towards the Q&A portion of this talk. Without further ado, let me invite Sarah Bird, founder of Responsible AI Area in Azure AI, to walk us through the content. Sarah, the floor is all yours.
Great. Good evening, everyone. At least it's evening here in New York. Thank you for joining us for this special Best of Build live session. We're going to be talking about some of our responsible machine learning capabilities, and in particular, how you get started and analyze your models. So, a lot of times when we think about responsible AI, people immediately think about some of the longer term challenges or some of the things we've seen in fiction. However, it turns out many organizations are struggling right now with challenges when they try to deploy AI responsibly. And so a lot of the tools and technologies that we're going to show you are very early. They're still being actively developed in the research community. However, because people are struggling today, we wanted to give them the state-of-the-art tools in their hands immediately, regardless of where the state-of-the-art is. In order to achieve this, we have a range of tools and technologies that we've been developing. In this session, we're talking about our first pillar, which is tools we have that help you analyze your models and get a deeper understanding of how the model makes decisions, how well it works for one group of people or another group of people, and questions like that. We also have additional capabilities that you can check out on demand or in some of our build recordings that are about protecting people's privacy and data. And we have additional ones that are features we're adding to the Azure Machine Learning platform to enable you to control your end-to-end machine learning process and the resulting systems. So as I mentioned, a lot of these capabilities are new and are still being actively developed. And so we wanted to be able to develop them in a way where we could respond rapidly to great new ideas and new innovations. And so we're developing a lot of the core capabilities in the open source where we can work directly with the researchers that are creating them. People who want to expand them to new applications can directly submit changes or expand the toolkit to work for their applications. However, machine learning, especially when you're taking it into production, is often better supported with a platform that can help you think about that end-to-end life cycle. And so we take our open source capabilities as they mature and we integrate them in Azure Machine Learning so that people can access them at the right points in the machine learning lifecycle. They can easily discover them and leverage the capabilities to maximum effect in their process. So let's get on to the topic, which is how do we really understand our models and the effects that they can have. So in this session, I'm going to be showing you a live demo. In fact, it's running in the background right now, where we're going to focus on a loan scenario. We are creating a model that is going to look at loan applications and decide which loans to accept and which loans to reject. In order to analyze this model and decide if we want to use it, we're going to use a combination of tools. We're going to use Azure Machine Learning as our base platform, and then we're going to use it in combination with Fairlearn to help us answer the question of, is my model fair? How well does it work for men? How well does it work for women? Then we're going to use InterpretML plus Azure Machine Learning to dive into that model deeper and understand why is it making the decisions it's making? How does it decide which applications to accept and which applications to reject? So let's go to the first topic, which is fairness. Fairness is a significant topic in AI development. It's one of the principles we have for responsible AI at Microsoft. And there's several different things you need to consider. In fact, there's many different ways that an AI system can behave unfairly. In the case of Fairlearn, the tool we're going to be using, there's two types of fairness harms that we consider. The first one is what we call quality of service harms, where the product just doesn't work as well for one group of people than another. For example, a voice recognition system might not work as well for male voices as it does for female voices. Or you can have harms of allocation, where I'm using the model to make it a decision that could affect people's lives, like whether or not they receive a loan. And I don't want that model to reject or accept people based on attributes that shouldn't be relevant in the loan decision. And so we need to analyze our models and understand if we're seeing any of these behaviors that could lead to negative outcomes for people. So as I mentioned earlier, the toolkit we have for this is Fairlearn. It's an open source toolkit which is designed to help you assess any potential unfairness in your model, and then allow you to use state-of-the-art mitigation techniques to address that unfairness if that's the right thing for your particular application. And I'm very excited to announce that I will be demoing today, and soon Fairlearn will also be integrated in Azure Machine Learning, so you can access the visualizations in the dashboard directly in the Azure Machine Learning Studio. So with that, I'm going to jump over and get started on the demo. So my demo is still running here. So we're going to get started at the top of the notebook while we let this run. As I mentioned, this is a loan scenario. I'm using the census data to build a model, which I'm going to use to decide whether or not to accept a loan application. So in the top of my notebook here, I'm just loading my data and pre-processing it, getting it ready for model training. The second thing I'm going to do then is, all of this is still just pre-processing the data. We're splitting it into training and test sets. And then I'm going to use scikit-learn here to train a predictor. I'm not doing anything special in this case to consider fairness. I'm just using my normal modeling techniques here. But now what I can do is, now that I have this model, I can take Fairlearn and I can use it to assess how well it's working across different sensitive attributes. So I have the dashboard here in the notebook, which we can use to understand the model fairness. So let's actually jump back over here and talk more about fairness assessment. So now that I have that model, I want to assess the fairness of the model. And so I'm going to make a couple decisions. First, I need to select which sensitive attributes I'm interested in understanding the differences between, for example, men and women, or by age, or any other sensitive attributes that are relevant to my particular application. The second thing I need to do is I need to select the performance metric that's the right one for my application. So in this case, we're looking at accuracy, but in another problem, you might care about precision or recall. After that, Fairlearn's going to look at the predictions and the real ground truth values and help you understand the difference in the performance of the model. Is it more accurate for men? Is it more accurate for women? As well as the difference in the outcome. Is it making different decisions for men and women? So let's go back over here. And because my notebook's still running, the interactive dashboard is not going to work in the notebook. And so I'm going to jump over and I'm going to show you this this feature that's coming soon, which is actually the integrated portions in Azure Machine Learning. And we're actually going to demo it over here. So here's the model I've been working on, and I've run it several times. So let's click in. And we can go to our last run here. And what I have is, all of the information about the model and my run. And I have a fairness tab where now I can go and actually look at that interactive dashboard and explore the fairness of my model. And so I have two different attributes in this particular data set. We have race, which has 5 values, and we have sex, which has 2 unique values. So I'm going to click on sex here. And then for my problem, right, we want to see, you know, how we want to measure performance. And as I mentioned earlier, in this case, we're going to look at accuracy. So I'm going to click through here, and I'm going to come back to what this this particular tab means. But this is my original model. So let's click on that, and let's understand the results here. So here's what we see, which is the difference in performance of the model. And so in this case, my model is about 92% accurate for women and about 80% accurate for men, which is leading to about an 84% accuracy overall. There's more under prediction than over prediction, and so now I can just kind of get a feel for that that question of how well is the model working for each person. However, since this is an allocation problem where we're actually deciding whether or not someone gets a loan, I also really want to look at, does the model make different predictions for men and women? And in this case, what I'm seeing is overall, I'm offering loans to about 19% of the people that apply. However, I'm only offering loans to 7% of the women that apply, but 25% of the men that apply. Now, the challenge here is I don't actually know if this is a problem. This might not be unfairness. It might be that the women that are applying are a very different distribution than the men that are applying, for example. And so all I know is that there's a difference in my model, and this is a sign that I'm going to want to go and investigate further and understand, why do I have this difference, and is that reasonable before I decide to move forward with this model. So with that, let's go back over to the back over here to the presentation, and let's talk about how can we better understand why this model is making different decisions for men and women. And the best class of techniques we have for that is interpretability. So interpretability is actually a collection of techniques that help you interpret or explain the behavior of models. So let me give you an example of why this is important and why you might want to do this. We have a paper on this from Microsoft Research, but we were creating a model to help understand which patients that have pneumonia are high risk, so that you could, for example, give them extra care to help improve their outcomes. However, we were training this on real data, and using interpretability techniques, we learned that the model had learned that if a person has asthma, they're lower risk. And if you talk to doctors, this doesn't reflect reality at all. In fact, patients with asthma and pneumonia are considered high risk. However, doctors already know that. And so in the real data set, they were potentially giving these patients that extra care, and the patients were having good outcomes. And so the model had learned something that was actually what was in the data, but isn't really what we want the model to learn if we're going to use this to help inform doctors. And so explanations can help you uncover model behaviors like this that would be undesirable if you use the model. So we have a collection of all of these together in an open source, actually family of libraries called InterpretML, where we provide both black box and glass box capabilities. And I'm going to talk more about what that means in a second. We also have new capabilities for text interpretability, so you can explain your text data, which is brand new at Build this year, as well as counterfactual explanations, so you can answer questions like, what would I need to change to be accepted for this loan? So there's a lot of great things here. And let's talk about glass box and black box models as two of the key types of interpretability. So glass box models are models that are designed to be inherently interpretable. It means they have a structure that we can actually inspect and use that to understand how they're making decisions. So for example, think of decision trees or linear models. However, there are more sophisticated, more accurate models available. For example, explainable boosting machines from Microsoft Research, which we have in InterpretML. And the great thing about glass box models is the explanations are lossless. You can completely understand how it's making decisions. However, in some cases, it might be that that model format doesn't work well for your problem, or you already have an existing model, for example, that you want to generate explanations for. And so in that case, you can use black box explanations, which we can use to explain any particular system. And the way that we do this is we perturb the inputs of the model and observe the behavior, which allows us to explain the behavior. However, the explanations are approximations. So we don't know perfectly if they are going to be accurate for our particular problem. However, in many cases, they do work very well. So with that, we're going to go back over to our demo and let's see where we are in terms of the notebook running. So I can, so we also could have, as I showed you the dashboard in the studio, but you'd see the same thing here in your notebook if you prefer to directly work in the notebook. So the next step, what's been running in the background here is I've taken that model and now I've used InterpretML built into Azure Machine Learning to generate model explanations. So I've generated global explanations, which are the explanations of the overall model behavior. And then I've also generated local explanations, so explaining why a prediction was made for any given individual data point. So I've generated all of those explanations here. And then now I'm going to actually visualize that, and I can open my visualization in a new tab here. So we can use this now to explore where we are and better understand why am I seeing that difference for men and women. And so this dashboard is brand new. We're demoing it for the first time here at Build, and it will be released in the open source and in Azure Machine Learning soon. We designed it by working with Microsoft researchers and practicing data scientists to really try to make explanations as understandable and as usable as possible. So in this case, let's go here, and I want to look at men and women. So we have this cohort capability that helps you slice your data into different dimensions so you can do comparisons. For example, you could do training and test data if you wanted. In this case, though, since I want to do this fairness analysis, I'm going to look at women. So I'm going to click on sex. I'm going to change this to categorical. Sex is represented by 0 in my, or women is represented by 0 in my data set. So I'm going to add a filter for that, and I'm going to save it. And now I want to add a second cohort, which is men. So I'm going to add this here, and we're going to go to sex. We will change it to 1, add our filter, and save. And so now what we're seeing is actually very similar to what we saw in the Fairlearn dashboard, but with more information, which is that the model is less accurate for men and about 92% accurate for women. We can also see the more details like the precision and the recall and the false positive and the false negative rates. However, what I want to show you here is how we can also then use explanations to go a step further and better understand our models. So I can click on the aggregate feature importance here. So these are the global explanations where we're going to look across all of the individual decisions. How does the model overall make decisions? And I have women here in blue and men here in orange because I set those up as my 2 cohorts. And so marital status is a significant predictor for both. However, what immediately jumps out here is the second column, which is sex. Which is apparently a significant factor in predictions for women, but not predictions for men. And I can click on it here and learn more. So now I can actually see the feature importance of the individual data points. And what I see is that for all women, the value of their sex being 0 is in fact contributing to the prediction to reject them. So that seems like a significant issue in the model. And I can then actually go, and if I want, I can dive deeper here, and I can perturb individual data points if I just want to get a feel for how this is working and how the features affect. So I can click on any one data point here, and in this case, you can see sex is the #1 predictor for this person, and they're currently rejected with a probability of 68%. If I want, then I can do a what if type analysis here, and I can change it to men. And now I have a new data point. And as you can see, in this case, we actually flipped the prediction. So by changing the person's sex, now they have been approved for the loan. So that seems like a pretty significant issue in this model. So I'm next going to move forward and show you how to mitigate it. But you can also, for example, click on multiple data points and see how it varies across them if you want to explore more than any one data point. So with that, let's talk about what do we do now that it looks like there's an issue in our model. So in Fairlearn, we have mitigation techniques that allow you to sort of directly improve the fairness criteria of your model. And so the first thing you need to think about is what's the right fairness criteria for your problem. This is a sort of famously published issue where there's many different ones that you can choose. The right one's going to depend on your particular application, your industry, a lot of factors. And so we make a variety of them available in Fairlearn so that you can use the one that's right for you. And then the second thing you need to decide is what type of mitigation algorithm do you want to use? It might be that you're not able to retrain the model, and so you want to use a post-processing method where, for example, I could calibrate the model and change it to have like a different threshold per group. Alternately, if you have the option, for example, to retrain the model, then we have reduction methods available where we can actually change factors and retrain the model and try to improve that fairness criteria directly in the model training. So I'm going to go and demonstrate that. So let's go back to our notebook and see where we are here. So what I've done now is I've used our grid search approach here, which is a reduction method that's been published in this research paper that you can check out if you want to learn a lot more about it. And my grid search is going to retrain my model. The criteria I picked here, see, is demographic parity. And it's retraining the model by reweighting the data different ways to try to improve that fairness criteria that I've selected. So here, it's going to train a variety of models. We're going to sort them to look at the best ones. And then I have my dashboard here. So if we click now, then I have the same features. So I can click through to sex because we want to look at the same problem, and I can click through to accuracy. And now what we see is that same screen that I skipped earlier, which is actually a range of the different models that I've trained that I can compare. So here I have that original unmitigated model that we dived into before that has about an 84% accuracy and about that 16% disparity. However, now I can also explore these other models on the trade-off curve. So let's look at this one. In this case, this one here it has a little bit lower accuracy, 82%. However, if I jump down here and look at the disparity in predictions, which was the metric I was trying to improve, in this case, now I'm offering loans to just over 15% of men and just over 14% of women, so a much closer number. So it might be that, okay, this model looks great to me, and now I want to take it and put it in production. Alternately, I could use InterpretML again to explore this one more and make sure that it's making decisions for the right reasons before I move forward. So my next step here is I want to save all these different models that I've generated. And so I'm going to register them all with Azure Machine Learning so that they're saved in my workspace and I can explore them later. So we're registering all of those models. I'm also going to upload the dashboards, which you just already saw, and upload all of those explanations. So now I have them available for future use, or if I want to share them with collaborators or other stakeholders. So in addition to the fairness, which we already saw here with the different models available, you also have the explanation tab built in, so you can go back to those explanations anytime if you want to do a different type of analysis or look at a different cohort. All of that's available to you here in the studio. So with that, I want to show you a real-world example of people using Fairlearn. So let's go to the video.
At EY, we fundamentally try to make the world a better working place through trying to put AI and cloud at the forefront of digital transformations. Our Trust AI platform is something that we've been building to help our clients really understand where the risks of AI are manifesting from. And now in the last couple of years, there's been a tremendous desire to use
Great,
machine
Sarah.
learning.
So I'll ask the...
Machine learning models are created by humans and thus are exposed to unfairness as a result. That can take the form of unfair treatment of individuals that are part of the protected groups such as gender, race, income, age, etc.
We use Azure Machine Learning and the Fairlearn open source toolkit to support our efforts on our Trust AI platform. And it is basically designed on different interrogations that we do of our clients' AI systems to better understand their risk profile and to manage those risks.
Fairlearn is a very, very cutting-edge approach towards fairness, which actually ensures our approach in using it going forward for all our different projects where we talk about fairness.
Because it's open source, we're seeing the latest in fairness algorithms and metrics within the tool. When we put Fairlearn to the test with real mortgage adjudication data, it improved the fairness of loan decisions. Before mitigation, the models had a disparity of 7% between men and women. After mitigation, the disparity was less than 0.5%. Our data scientists and IT teams use ML Ops to help accelerate their work while maintaining fairness levels. We monitor every step of the process using the ML Ops capabilities in Azure Machine Learning.
Microsoft's been a real leader in recognizing the need for ethics and responsibility in regards to how we think about responsibility AI. This is filling a real need of our clients. They're seeing more successful AI deployments, which is translated to greater trust in their AI systems, and ultimately an acceleration in achieving their desired business outcomes.
So if you want to learn more about the topic of responsible AI or any of the tools or technologies that we demonstrated today, we have a ton of great resources in our Microsoft Responsible AI Resource Center. We have responsible ML pages for Azure Machine Learning, as well as documentation on how to use these tools with AML. And of course, all of the information about the core toolkits is available on the GitHub pages. There's many more sessions at Build that you can watch to learn more. And with that, let's open it up for Q&A.
Awesome. Thank you very much, Sarah, for walking us through such an insightful session. The first question that we usually get when we talk about Fairlearn is, why not remove the sensitive attribute from the training data?
Yeah, it's a great question. And there's different schools of thought about this. And in fact, depending on regulations in your problem setting, the right thing to do here may be different in terms of whether or not to directly use the attributes in the data. Now, of course, the advantage of using the attributes is that you can do things like the post-processing techniques we talked about. And even if I remove the attribute, it might be that that is still represented in the other features in the data set. So I might still see the same effect without directly having the attribute. So it's not so straightforward.
And one very quick question, and feel free to close the session. Can we support PyTorch and TensorFlow models, basically models trained via these deep neural network frameworks?
Yeah, so you can check out the READMEs on the GitHub to get the latest information, both of like what model types we support, as well as all of the different algorithms in the toolkit, links to the research papers, everything that you might need. And yes, we do support PyTorch and TensorFlow and Scikit and a lot of the common model types that you'd want to use.
Thank you.
So with that, I'm going to say thank you for tuning in. We hope that this was useful for you and that you check out the tools and use them as part of your responsible AI development toolkit.